This video explains transportation problem. For this transportation problem, we have to use linear programming. Linear programming is optimization technology. Uh, for this problem, we have to minimize the total transportation cost. Actually, we have 4 different cities and we have a 4 different customer area. We have to deliver some quantity from Atlanta to certain customer side. From Fort Worth we have to deliver some customer, but also we have their capacity, and we have a demand. And from here basically we can think about this kind of objectives. So objectives will be here we can consider 4 different city: Atlanta, Fort Worth, and Tucson. There are 4 different cities, and also we have a 4 different 3 different supply side capacity, and the 3 different customer side. And then we have to decide you know transportation quantity from Atlanta to Believa, from Atlanta to Dude World, and from Atlanta to Slickers, from Atlanta to CJ's, and like this. So we have to decide this transportation quantity. So how much they have to deliver. So that is our major decision variable. So out of this, we have to decide all transportation quantity from each location, each city to each customer site. And at the same time, we have to minimize our cost. This graph, this chart shows our general visualization chart, right? And for this, we can say we have to minimize our total transportation cost, transportation cost, right? And also we have 2 different perspectives. One is from this each location, we cannot deliver more than their capacity. We cannot deliver from Atlanta, for example, we cannot deliver more than 20,000. For Fort Worth, we cannot deliver more than 40,000. For Tucson, we can deliver more than 30,000. So those are supply side constraint. Also demand side. For demand side, also we have to satisfy all demand. So from Atlanta, from Fort Worth, from Tucson, for these 3 different places, and we have to deliver at least 27,800 for Dude World, from Atlanta, Fort Worth, from Tucson. So total transportation quantity to Dude World should be greater than 8,000, and the Slickers total transportation quantity to Slickers should be more than 13,500. And for CJ's, same idea. The total transportation quantity to CJ should be more than 33,000. So we have 2 different type of constraint. This is the basic ideas of our transportation problem. To do that, we have to build up all these equation. So I will write down our basic objective function and our constraint. So now, first of all, we have to put all information trends. So we can type all the trans cost actually from Atlanta and Fort Worth and Tucson, and also we have Believa, we have Dudeware, and we have Slickers, we have CJ's. Then we have to input their cost. Cost should be $2, $5, $1, $3, 1.75, and 2.5, and the Slickers 3.5, and 2.25 and 1, and CJ 1.5 and 4 and 3. And also we have their capacity. I just skip one column. Capacity is 20,000, 40,000, and 30,000. So we just put this information. Demand should be 27,800, 800, 8,000, 13, 500, 33,000. So we have this information, and also we have to decide transportation quantity. So transportation quantity is has same format. So we don't know this quantity, but we have to decide this quantity. So that's why I will use different color. And also we can transportation quantity, quantity 2, actually 2, this is actually 2 millibobs is actually sum of these quantity. So this yellow cells are our transportation quantity. Then we can define this, and also we just use the same idea. Then this sum is a total quantity, total transportation quantity, dude ware, and the next one is same ideas, liquors, CJs, and so on. And this transportation quantity should be greater than our demand. Our demand is this quantity, right? So we have this given quantity, right? Also at the same time, and we can define our transportation quantity, from, means if you add this sum, means this sum is what? This sum is we deliver some quantity from Atlanta to Bolivar, from Atlanta to Dudeware, from Atlanta to Slickers, from Atlanta to CJ's. So if you add all this, that is transportation quantity from Atlanta, right? So this is same idea, and this transportation quantity cannot be greater than their capacity. So actually their capacity is defined here. So we can use this, right? Then this is just visualization. And finally, we can compute our objective function, which is a transportation quantity, transportation total cost, total transportation cost, total cost. And to do that, I just simply define these three. Then I just highlight all these, and then I can define here. This is a trans cost, and also I highlighted this, and then I just define here. This is a trans quantity, and for this, and total quantity should be total transportation cost will be individual quantity times their unit price, individual quantity times their unit price, and then we can add all this, that is some product function. So then we can use trans quantity times trans cost. Then this is multiplication and the sum, that is some product. So this is our total transportation cost. And this is just simple implementation, just express all basic information. Now we have to build our optimization model in Excel. To do that, you have to add a solver. You have to reflect all this idea into solver. Solver is optimization tool. So here basically, first of all, you have to define which one is our total cost. The total cost is here, and we have to minimize. You have to define direction, and what is changing variable. Actually, we have to change all these variable. This is actually trans quantity, right? Trans quantity is our decision variable. You can define all these, or you can say trans quantity. This is also another way. And now we will define two type of constraint: demand constraint and capacity constraint. So first of all, we will add the demand constraint. For demand constraint, this transportation quantity, sum of transportation quantity should be greater than our demand. Our demand is defined here, so you can add. And then next, capacity constraint, this transportation quantity should be less than our given capacity. So we can say that, and then click OK. So we add these two constraints. So you add these two types of constraint, and you can check unconstrained variable, non-negative, and we use simplex LP. And then now we are ready to solve, and you can click solve. And if you click solve and Excel is running, solver is running, it takes time to get some result. And if you have result, and then you can save this answer report, and also you can click sensitivity and so on. But we just read our answer, final answer. But it takes time. If you click this answer, and there are lots of information here, and also they provide some sensitivity analysis as well, but we do not read all this, but we just read this number. So now look at these numbers. So first of all, here from Tucson, from Atlanta, they deliver CJ only. So actually from Atlanta perspective, which one is the cheapest place? CJ is the cheapest place. So that's why Atlanta case, they just deliver whole quantity to CJ only. And how about Fort Worth? Fort Worth, Dudeware and the Slickers are best one, so you can deliver these two. And then third option, Atlanta case, Fort Worth case, they have a large capacity, so that's why they deliver 3 different places, right? And Tucson case, which one is best case? Tucson, actually Billy Bob and the Slicker, so that's why they deliver these two. But some case, if they do not have good chance, then probably even if they do not have this kind of best cheapest alternative, but they cannot deliver, because if some case some city may compete against each other. If they do not have enough demand, enough capacity, then probably we can choose the second best from first perspective, from some city perspective. But however, for this case, they just choose the best, cheapest place. This is kind of best scenario, but some case it cannot happen. But anyhow, for this case, if we use this kind of solution, then this is the best scenario. So this is best. We can minimize their total transportation cost. If you change this kind of total transportation cost plan, then probably you might have some more expensive total transportation cost. And I hope you run linear programming. I mean, you know how to run linear programming for this example, not any other example for this class. And then click solver, and you can save this object set, object function, direction, transportation cost is our decision variable. You can define two types of constraint, and you have to select simplex LP and then click solve. And if you have different data, different cost information, and you can rerun, and you will get those results. Also, if we change this coefficient cost information or demand information, then we can analyze those sensitivity report. We can read this sensitivity report, but that is beyond of our scope. But at least you can run this kind of problem using this LP solver.